Now let's do the proof of theorem 3.7. So remember, we want to show that T of W. So when you read this again, that's a set. T of W like that is an actual set. So that set we need to show is a subspace. So what do we need to show subspace? To show subspace, as you recall, you need to show closure. So you want to show the zero maps to zero. That'll be easy. But then you show closure in that subspace. So let's take a look. So first, recall that zero maps to zero. So T of 0 is equal to 0 prime. So we showed that for all linear transformations already. So then we know W is a subspace of V. So for any two elements arbitrary, so for W1 and W2 in W, the sum W1 plus W2 is also in W, because that's assumed to be a W is a subspace, so it already has closure. Okay, and T of W1 and T of W2 must also be elements of T of W, because that's the definition of the transformation itself. So we want to show the sum is as well. So if you just do the sum, but then T of W1 plus T of W2, so that's what you would do next. You show the sum is also, or is in the subspace. But you can rewrite that as T of W1 plus W2. Now, W1 plus W2 is another element in W from here. So that's like saying T of like another vector, which is the definition of the transformation. So that's also then an element of T of W. So that's closure for addition. So now we want to do for scalar multiplication. So also for R in R, we have R W1 and W. That's because it's closed under scalar multiplication for W. And RT of W1 is equal to, so this is the scalar multiple part. So now you can apply the definition, the second part of the transformation definition. T RW1 is also in T of W, because RW1 is an element in W. So that's by definition going to be also in T of W. So therefore, T of W is a subspace of V prime. So for 2, it's really a similar argument. So we won't go through the whole thing. So for 2, or we'll just say similar proof. And argument. All right, so look, check that out. Look at that proof. Just a couple more things to do in this section. We want to talk about, I'll do this in another video. We want to talk about one-to-one again and onto and isomorphism. Really just talk about the concept and what that means. Something I want you to study. So we have a couple more things to look at, and that should wrap up chapter 3 stuff. And I already sent you posted the sample exams and things like that online. So you